Hello everyone, in this video we are going to do the chapter ammonia, and those who are watching for revision you can go with the speed of 1.5, and those who are watching for first time to study this chapter you remain with the same speed, that is 1.0. and if you are watching for first time to study this chapter for first time, then you can make your own notes as well, that will be more beneficial. So let's start chapter ammonia. Ammonia is also known as alkaline air. Ammonia is also known as alkaline air. It is colorless, basic gas and pungent choking smell and bitter taste. Alkaline basic. It is alkaline basic and its taste is basic, bitter taste, and its smell is pungent choking smell. Now structure of ammonia, that is NH3. Its formula is NH3. So nitrogen is 1 and the hydrogen is 3. And nitrogen's outer valence shell have 5 electrons because its atomic number is 7, so it will have 5 electronic configuration. So 5 electrons are in the outer valence shell, and hydrogen is having one electrons in the outer shell only, and so hydrogen needs 1 more to get stable and nitrogen needs 3 more to get stable. So hydrogen and nitrogen will share with each other. Hydrogen share one electron shared with the hydrogen. Now this hydrogen is stable, and now again this hydrogen is stable, and downside this hydrogen is stable, and nitrogen also gets the 3 electrons from the hydrogen. So now it becomes 1 2 3 4 5 6 7 8. Now it's stable, but 2 pairs of electrons remains unshared. So that unshared pairs electron known as lone pair, that is known as lone pair. And reason for the basicity of ammonia is this one only, lone pair, which lone pair is the reason for basic nature of the ammonia. And now this is calcium hydroxide, that is known as slacked lime, and calcium oxide that is quick lime. Laboratory preparation. So setup is like that. Here is the Bunsen burner, and then a tilted flask is connected with the tube in the another chamber, and then the chamber is again connected with the collecting chamber, and here is a stand which holds these two in their places. So now the process is like here, ammonia plus water is heated highly, and then it forms the vapor. Vapor moves to this chamber through the tubes, and then here in the chamber, in the above part, there is a drying agent fixed, that is calcium oxide. Then after filtering from the drying agent, then water is getting absorbed, and then the ammonia is only passed and it is collected here, and it is connected by downward displacement of air, ammonia gas. Now it's what we say, reaction is like ammonium NH4Cl means ammonium chloride plus calcium hydroxide will give ammonia plus water plus salt, that is calcium chloride. This is the process how it get ammonia. So now moving to the next part, that is laboratory preparation of ammonia. That is the reactants is ammonium chloride plus calcium hydroxide. This is cheap, and so its ratio is 3, and ammonium chloride is means what to say, costly than the calcium hydroxide, so its ratio is 2 only, and it gives salt plus water plus ammonia. So the ratio is in 2:3 because to compensate for the loss due to sublimation of ammonium chloride. And potassium hydroxide and sodium hydroxide is deliquescent, absorbs moisture but not used. Now the next part is ammonia is collected by downward displacement of air, because ammonia is lighter than the air, and NH3 is highly soluble in water. This we know by that process only. What was that fountain experiment that we have discussed in the last video? You can watch that video that was HCl chapter, and HCl chapter and NH3 means ammonia both having the fountain experiment for proving that ammonia and HCl is highly soluble in water. Now moving to the next, flask was tilted because water vapor doesn't trickle back and break the glass, so that water vapor which was formed after heating don't get back and break the glass. Now the next question is, why concentrated sulfuric acid and pentoxide etc. cannot be used for dry ammonia? Because since they react chemically with the ammonia. Now the next is ammonium nitrate not used instead of ammonium chloride. Why? Because ammonium nitrate is highly explosive and it decomposes as well. So now next is, from metal nitrides we can also form the ammonia, but why we are not using it regularly? Because it's too costly and it's so used, and so it is used seldomly. Now it's what we say, reaction is like metal nitride plus hot water will give ammonia plus metal hydroxide, like magnesium nitride plus water will give ammonia plus magnesium hydroxide. Here aluminum nitride plus water should be in hot, extremely hot, and so it will give ammonia plus aluminum hydroxide. Now the next is NH3 dry is not basic. Dry ammonia is not basic, but aqueous solution is basic due to basic due to OH ions, presence of the OH ions. The aqueous solution of ammonia is basic in nature. So we will see here, ammonia plus water forms the ammonium hydroxide, and so when ammonium hydroxide gets splitted into two, then it forms ammonium plus OH ions. So because of this only the ammonia is basic in nature. Now the next part is reactions due to basic nature. When we will react with the basic nature of the ammonia, what we will get? Acid plus base NH3-Ammonia will give ammonium chloride, dense white fume, and this was the only one reaction which contains all three bonds: electrovalent bond, covalent bond, and the coordinate bond. And this is the only this is also a test for the ammonia. Tests for ammonia. And now again the next reaction is sulfuric acid plus ammonia will give ammonium sulfate. Note means it's the note point, that is water is not formed reacting with the dry or liquid ammonia. Here ammonia is in dry state, and so the water is not formed. If we can see here, water is not, water we have written, but water in the reaction is not formed, and it's even not liquid, so it's in gaseous state. Ammonia gaseous state, not in liquid aqueous state, so water is not formed. Now the aqueous ammonia plus acid will give salt plus water. Here see, ammonium hydroxide, we have seen that ammonium hydroxide is the aqueous state of the ammonia, plus HCl will give ammonium chloride plus water. Here also ammonium hydroxide plus sulfuric acid will give ammonium sulfate plus water. And NH3 is also a good reducing agent. So the reaction is like copper oxide plus ammonia will give copper plus water plus nitrogen. Here from copper oxide, oxygen is being reduced to water. Here copper oxide is being reduced to copper, and so oxygen is taken out from copper oxide, so it is known as reduction reaction, and so it is the reducing agent. Ammonia is the acting as the reducing agent here, and the color is copper oxide's color is black in color, and the copper PPT is red PPT. Now the next reaction is PbO, means lead oxide plus ammonia will give lead and plus water plus nitrogen. Here is also like same, lead oxygen is being reduced from the lead oxide. Now the reaction with the chlorine, this reaction is very important. I have seen in previous year's question paper this reaction coming in many years paper. So the reaction is like chlorine plus ammonia. When ammonia will be in action, the formation of products are nitrogen plus ammonium chloride, that is dense white fume, and this nitrogen is greenish, is disappearing after this reaction. Then when chlorine will be in excess, then plus ammonia will give HCl plus and Cl3, known as nitrosyl, and it is in yellow liquid. combustion of ammonia not burns in air, means ammonia not burns in simply air, burns in pure oxygen. And it burns in pure oxygen. So ammonia plus oxygen will give nitrogen plus water, and nitrogen is in yellowish green flame. And reaction with oxygen in the presence of catalyst, reaction with the oxygen in the presence of catalyst, that is ammonia plus water will give in the presence of platinum with the room temperature of 800 degrees Celsius will give nitrous oxide plus water. Then when again nitrous oxide will react with the oxygen to form nitrogen dioxide, that is reddish brown gas. You all have to learn this all reactions, these both reactions is also very important. I have seen in the last year question papers. And this is exothermic reaction because platinum continues to glow red after heating is stopped as also. And so this was the combustion of ammonia. Now the Hybris process, this is also very important. Now in this process we are taking the reactants nitrogen plus hydrogen in the ratio of 1:3 in the presence of some catalyst, promoters, and temperature and the atmospheric pressure, that is temperature is 450 degree to 550 degree Celsius, atmospheric pressure is 200 to 900, and then the what we say catalyst is iron, finely divided iron, and the promoters is molybdenum or the aluminum oxide, and it will give then ammonia plus heat. We have to take some certain steps while doing this process, means that precautions. Ammonia and hydrogen should be free from the impurities like carbon dioxide, carbon monoxide plus hydrogen sulfide, else it will poison the catalyst. Collections, how we are collecting the ammonia by condensation, liquefying or dissolving in water, and ammonia is highly soluble in water, we must know, and liquefying, ammonia liquefies very easily compared to nitrogen when compared to nitrogen plus hydrogen. So the process setup is like we are taking hydrogen plus nitrogen with the volume of 1:3, nitrogen 1 and hydrogen 3, and then with the high pressure, that is 200 to 900 atmospheric pressure, we are compressing in the compression pump, and then again it moves with the tube to the again what we say promoter and catalyst part, from where the reaction gets the boosts. Molybdenum is the promoter and the finely divided iron is the catalyst, with the temperature of 450 degrees Celsius to 550 degrees Celsius, and again the heat exchange is taking place, then it moves to the next condenses chamber. This was the catalytic chamber, and so here all the catalyst and promoters were used to boost the process, and then again it moves to the condensed chamber. Here cooling or ammonia liquefied, ammonia is collected in the another chamber outside which is connected, and again the remaining what we say reactants again sent to the compressing pump. Again the process continues till the complete ammonia is being extracted, means taken out from this and ammonia, nitrogen plus hydrogen. So this chapter is completed. Thank you.